cheese, glorious cheese.
Go ahead, pile it on.
It's the heart of a pizza.
Pile on some more.
Cheese, glorious cheese.
Keep it on frozen pizza.
Try adding some extra.
After all,
So here is a simple diagram of the cheese making process. Today in the background you're going to be seeing a video of me actually making a 2-ingredient cheese called paneer. It's an Indian cheese and it's unaged, so that means that it doesn't have to sit after it's coagulated. It actually can be eaten almost instantly. Well, it does have to sit for 15 minutes to however long you want it to be firm, but you don't have to let it sit before you eat it. So we all know that cheese starts with milk. So bacteria has to be added to the milk to lower the pH. So the main bacteria that are used in the process of cheese making are mesophilic bacteria and thermophilic bacteria. The addition of the bacteria is the first step, and this bacteria converts the lactose found in the milk into lactic acid, which lowers the pH of the milk. So the next important thing to know is that what milk is made out of. So milk is made out of many protein particles, and that includes whey protein. So more than 80% of these proteins are formed into casein micelles, and we learned in class that micelles are a spherical structure that is amphipathic, and the negatively charged part of the micelle repel the other casein micelles, and it causes the milk to stay in a liquid form. So something that's added is called rennet, which is a substance that contains an enzyme called chymosin, which dissolves the negative end into liquid and allows for coagulation. So in this video, you're going to see me use vinegar and put that into my milk while it's simmering, and when this happens, you can see the milk start to coagulate. So during the coagulation process, this is when the whey proteins in the milk denature. So denaturing is when the structure of the casein micelles is changed, and that is why it begins to clump up, and that's why you can see it clumping up, and now I can put it into my cheesecloth and actually structure my cheese. So the vinegar in this video acts as rennet, which is a substance that contains an enzyme. So soft cheeses like cream cheese coagulate slowly, and harder cheeses such as Colby Jack and Swiss cheese have a faster coagulation process, and it results in firmer curds. So this cheese isn't going to be that firm, but it's going to be firm enough for me to cut it. So the important part to know is that soft cheeses stick together around a pH of 5.3, and hard cheeses will require a even more acidic pH. So these are the basics to the coagulation process in cheese, and I hope that this starts to highlight how our chemistry class has showed us how chemistry works in the real world, which cheese is something that's really popular, and I personally never knew how to make cheese, but it was a cool experience actually learning about the chemistry of cheese and then seeing it. I didn't think that my cheese was going to coagulate the right way and as quickly as it did, but as soon as I added that vinegar to it and the pH lowered, it immediately started changing the shape of those proteins and creating clumps that worked into my cheese. So you're going to see that after I put it in here, I had to let the cheese sit for a little bit so that it could get a little bit firmer so that I could cut it and show you guys that it was actually cheese. But I actually let the cheese sit for 24 hours, and it was even firm enough for me to cut.